evaluate the following definite integral. So here we have one of those obscure antiderivative formulas for an inverse trigonomic function. So to get us started here, I just want you to recall that for a real number k, so for some constant k, that if you have the integral of 1 over k squared plus x squared dx, that this is equal to the inverse of tangent of x divided by that constant k all over that constant k plus your arbitrary constant c. And so this is the formula that we're going to need to use here to integrate. So to get us started, I'm just going to rewrite this. I'll pull that constant 4 in the numerator out in front of our definite integral. So this is 4 times the definite integral from 0 to 2 of 1 divided by 2 squared plus x squared dx. And so now we can see how this directly applies to the antidifferentiation formula above. So this becomes 4 multiplied by inverse tangent of x divided by 2 all over 2. And we have the definite integral from 0 to 2. And so we can simplify. We know that 2 goes into 4 2 times, which leaves us with 2 multiplied by the inverse tangent of x all over 2. And we can now evaluate from 0 to 2. So this is 2 multiplied by the inverse of tangent of 2 divided by 2 minus inverse tangent of 0 divided by 2, which will simplify. So we can rewrite this as 2 multiplied by inverse tangent of 1 minus inverse tangent of 0. And we know that this will be 2 multiplied by, so again, if you're a little rusty on your inverse tangent evaluations, remember that y is equal to tangent of x, and we restrict those bounds so that x is strictly greater than pi by 2, strictly less than pi over 2. And this is equivalent to arctan of y being equal to x. So we think to ourselves, if we have the inverse tangent of 1, what x value is going to produce 1? And so we can recall, we know, of course, that tangent of pi over 4 is equal to 1. So that means that inverse tangent of 1 is going to be equal to pi over 4. And we do the same thing for inverse tangent of 0. We think what x value will make tangent equal 0. Well, there's only one case that does that, 0, within these bounds. So we can say that the inverse tangent of 0 goes to 0. So we have 2 multiplied by pi by 4, and we know again 2 goes into 4 2 times, for a beautiful final answer of pi by 2.